Duolingo is a language learning platform with over 200 million users. I've personally used it to learn some Spanish. On a daily basis, millions of users receive customized language lessons targeted specifically for that user. These lessons are generated by a system called the Session Generator. Kenji Horie is a senior engineer at Duolingo, and he wrote about the process of rewriting the Session Generator, moving from Python to Scala and changing the architecture at the same time. In today's episode, guest host Adam Bell talks to Andre about the reasons for the rewrite and what drove them to move to Scala, as well as the experience of moving from one technology stack to another. Cloudflare runs 10% of the internet, boosting the performance and security of millions of websites. Many of you probably already use Cloudflare on your sites, but we're not talking about using Cloudflare today. We're talking about building on top of it. If you're a developer, you can build apps which can be installed by the millions of sites which rely on Cloudflare. You can even sell your apps. They can make you money every month. Your users can log in or register to your service inside your app. They can get a real-time preview of your tool live on their site, and they can start paying you monthly, all from within Cloudflare apps. They can go from never having heard of you or your service to having it installed on their site and paying you in seconds. Visit cloudflare.com/sedaily to watch how you can build and deploy an app in less than 3 minutes. That's cloudflare.com/sedaily. Thank you to Cloudflare for being a new sponsor of Software Engineering Daily.
Kenji Horie is a senior software engineer at Duolingo. Andre, welcome to Software Engineering Daily.
Oh, hello. Yeah, welcome for inviting me.
Yeah, you have a great sort of case study about the rewrite work that's been done at Duolingo. But before we get into that, I was wondering if you could explain what Duolingo is.
Yes, so Duolingo is a language learning app. We have around 200 million users as of today. And in the app, people can learn a new language by doing exercises and translating sentences from their language they're native on to the language they want to learn. And then we have other exercises that practice listening skills and some reading skills, some grammar skills.
It tries to make it sort of a game to learn a new language. Is that correct?
Yes, that's correct. We have all of the gamification mechanisms such as hearts, levels, experience, all of that to make the language learning experience more engaging, because when you're learning a language, that's the sort of process that takes people like several years to become fluent in a language, right? So by gamifying it, we make it easier for users to keep learning and keep engaged so that they can achieve this very long-term goal.
Mm-hmm. How big is the engineering team at Duolingo?
Engineering team should be around 40 to 50 people, maybe.
And how is that organized?
So we have several teams. So we have some product teams, which we call product teams. For example, we have the learning team, which is the team that focuses on improving our learning metrics, improving the learning experience to users. We have, for example, our growth team, which is concerned with expanding our user base and keeping people engaged. And we also have some more foundational teams, like, for example, Q&A or operations.
Which team are you on?
I'm in a team called the architecture team. So it's basically guaranteeing that we have a healthy code base or a healthy system in terms of in the application level.
So would your tasks be around sort of setting standards around what languages are used or what frameworks or things like that?
That also, so languages used, also maintaining like common frameworks and libraries for the rest of the company to use, making sure that the architecture as a whole is healthy and each microservice is doing correct things and not abusing our infrastructure.
You were involved in a rewrite of the session generator. Could you explain what the session generator is?
Yes, absolutely. So, when a user is learning Duolingo, they will need to learn somehow. So we give users exercises, and we have a pool of exercises, which is pretty large. So actually, let me take 2 steps back. We have a product called the incubator. And in that product, we have volunteers making the courses, the courses that our users see. So it's like a crowdsource approach. And the volunteers will input all of the data and will make the course structure and write all of the course content. And then the session generator is responsible for pulling all of the data and picking the exercises that will be the most interesting for the user at that point, and give it a session that is bite-sized and small for the user to do, let's say, in a bus or wherever they are.
So a session is like a unit of learning, and the session generator creates that unit?
Yes, that's correct. A session is, simply speaking, is a collection of exercises.
Okay. So is this session generated on the fly, or is it created ahead of time?
Part of it is on the fly. We have a lot of pre-processing going on because there's so much data involved in each session that if we do every single step on the fly, then that's very time-consuming.
Why couldn't all the, say, Spanish sessions be created ahead of time? Is there information?
Yes. So we also want the sessions to be adaptive for each user, right? So for example, let's say a user knows 10 words and some other user knows 50 words. So the sessions for these two users will be different. And also we take into consideration how likely they are to remember a word and other things like that. So it's very important for these sessions to have this online component.
How do you figure out when somebody's going to remember a word?
So we have a model for that. So there's this thing called the forgetting curve for a word. And it's basically the probability that a user will forget or will remember a word after a period of time after they've learned. Let's say that 1 day later, they have a probability of remembering that's X. 2 days later, the probability will decrease. And so we model that as in a curve, and then we do some sort of regression to estimate how well the user knows each of the words.
So if I learned that like garçon is man today, then you figure out based on certain probability, like I'll probably know it tomorrow, but not next week, and then you reintroduce it?
Yes, that's correct.
So why did you decide that a rewrite was required? So you have this session generator. It takes into account these kind of forgetting curves and builds a lesson on the fly, I guess.
Mm-hmm.
So why did you decide you needed to rewrite it?
Yes, so it all starts with the monolith, I guess, and all of the nightmarish stuff started with a monolith. So we have the monolith, and it's written in Python. And the thing is that in the first years of a startup, we are all thinking of, let's move fast, let's ship quickly. And after some years, we end up adding a lot of dependencies like data stores and other services and whatnot. And in the end, the entire system becomes very, the performance is not so great anymore. And also the site's not as stable. And that's so one of the reasons is to re-architect the whole system so that the system is more robust. And the second reason is that we have the code in Python, and Python is a great language for writing things quickly and having like prototypes ready very fast. But for systems that are very large, that have like very complex data structures and complex algorithms, then Python is not so great because let's give an example. So something as simple as dynamic typing becomes a nightmare because then you don't have all of the niceties that you have in a strongly typed language because the compiler won't do as many checks, for example. And then the developers lose confidence in writing code, and then they have to spend a lot of time testing to see if all of the possible corner cases are being caught and nothing's going to break in production.
So let's see if I understand it. So we have this giant Python monolith. So as you add new features, it keeps on growing. You're saying the problem with Python is when you want to add something new, like your level of confidence is low because of dynamic typing. Do you have an example maybe to explain that?
An example? Sure. Okay. So, I'll give a very simple example, which is let's say we want to rename a function. And I mean, you could grab your entire code base and start changing stuff, right? But it's also possible that in some part of the code, you pass that function as a lambda, and it has a different name somewhere, and then your code breaks in production. Or, for example, if you want to add another argument to a function, then you have to guarantee that also nothing is going to break, but then it's also very hard to find all of the occurrences, or that or for example, even simple things as you don't know what data type you're getting into a function. So you can assume you're getting something, but in the end, you're getting something else. And these are all things that a simple compiler check could figure out and say that you're doing it wrong. But since Python doesn't have that, then it's very easy to break stuff.
Did unit tests help with this process at all, or were there tests? Or
so we do for part of the code. Yeah, so unit tests definitely help, but in the starting years of a startup, I guess people are more concerned about shipping things than writing unit tests. And it gets to a state that even parts of our code base are very difficult to mock with a unit test, or part of the monolith. Because after a while, we learned from our mistakes and realized that, we can architect things in a different way that makes unit tests easier. But in the monolith, there are still many places where it's very hard to write unit tests, very hard to mock things.
Especially, if you didn't have unit testing in mind, sometimes you make decisions that make it hard to add them after the fact.
Yes, that's very true.
So when you decided to do this rewrite, what made you choose Scala?
Yeah, so there are some reasons. Well, the first is that our infrastructure is built on top of AWS. So yeah, we needed to think of the languages that are natively supported by Amazon, right? And they are, Python, JavaScript in Node.js, JVM-based languages such as Java, Clojure, and Scala. And I think Go is also one of the supported languages. And JavaScript has the same problem as Python. It's weakly typed. And this is something that we wanted to avoid for the particular case of the session generator. And then Java is, it's well known, and it's a bit slow and it's slow to develop, and it's very verbose. So we wanted a more modern programming language, which is why we thought that Scala was might be a good choice, and also because Scala is also very mature in the backend, and it's used by many applications in the big data domain. So, and big data is kind of similar with what we're dealing with the session generator, right? Because it's like there's also like a lot of data, complex data structures, complex algorithms, and it seemed to be a very good fit.
Was there any concerns about the learning curve of a language like Scala? I mean, it has a reputation for being somewhat complex.
Yeah, so we had concerns. Right now, since our entire engineering team is small and the number of people dealing with Scala is also small, my population of people who learn Scala here in the company is also very small. So I don't know how good we can talk about like how easy it is. But up until now, I personally thought it would be harder for me and for other engineers to learn Scala and to get going, but it was it was a lot easier than we anticipated.
Let's discuss some of the features of Scala that you found useful in your rewrite.
Mm-hmm.
So could you describe referential transparency?
When we have referential transparency, we have a method that the only thing it does is calculate the output and doesn't change any state anywhere. So it's very easy to unit test and to also to just logically debug what's going on, because you know that once you have that, once have some input, the output will always be that one, always be what you're expecting. Yeah, or what. So it makes things very easy to test, to reason about, and that's one thing that's very good once you have like very complex data structures.
The octopus, a sea creature known for its intelligence and flexibility. Octopus Deploy, a friendly deployment automation tool for deploying applications like .NET apps, Java apps, and more. Ask any developer and they'll tell you that it's never fun pushing code at 5 p.m. on a Friday and then crossing your fingers hoping for the best. We've all been there. We've all done that. And that's where Octopus Deploy comes into the picture. Octopus Deploy is a friendly deployment automation tool, taking over where your build or CI server ends. Use Octopus to promote releases on-prem or to the cloud. Octopus integrates with your existing build pipeline, TFS and VSTS, Bamboo, TeamCity, and Jenkins. It integrates with AWS, Azure, and on-prem environments. You can reliably and repeatedly deploy your .NET and Java apps and more. If you can package it, Octopus can deploy it. It's quick and easy to install, and you can just go to octopus.com to trial Octopus free for 45 days. That's octopus.com, octopus.com.
So an example, just it's helpful for me and probably the listeners, if I can tie it back to an example. So referential transparency means you have a function with some amount of inputs. So let's say like the words that I know in Spanish, and then the output is. Or do you have an example of where that could be used?
Yeah, sure. So let me think. Okay, so let's say some part of the algorithm, we are thinking if we should choose an exercise A or an exercise B, and we put both into the function, pass them into the function. And so what happens with referential transparency is that first there are not going to be any side effects. So we won't write things to the database, for example, because that will be adding a side effect. Or we won't be changing something inside one of the objects, because that doesn't contribute to the output, right? And the idea is that we will just do some calculation, and that calculation will be used only for the output. So let's say if we wanted to pick between two exercises, the output is simple, it's one of them, but we can guarantee that nothing else is going on.
Which is what makes it easy to reason about.
Yes, correct.
You also mentioned, and I think it ties into that example, about immutability. So how does immutability tie into this?
Well, immutability, it's if you think that your data, like when data is immutable, first you have some nice properties, like you don't need to think if something is changing your data from somewhere else. And I think many people have seen you call a function and then you pass an object to a function, that function calls, and that function calls another function, and somewhere along the way someone changed one of the properties, and then you don't know who changed it, what it changed to, and you just need to like add print statements all over the place to figure out what is going on because something changed part of your data and you don't know why. So when you have immutability, you're guaranteed that, well, things won't change. So in each step of your algorithm, the state will be very clear to you. So, and what this means in the context of Scala, for example, is that in each step of your algorithm, what happens is only data changes. So let's say you have a list and you change the elements of a list by, let's say, adding one to some property. And then you know that in your next step that your new list will have all of the elements with +1. And you know that you're guaranteed that that's going to be that forever. So if you use that variable for something else, that value will always stay the same.
Mm-hmm. So, but you did say the list, we're adding an element to it. So how can something be immutable when we're adding to it?
Yes, that's a good question. So what we do is we actually copy the list. So we have the original list, we have the new list with +1 in all the elements. And then we keep just transforming data as we go. And that's a way that functional programming happens, is that you will always generate new stuff, but you won't be changing what you had. Because if you change what you had, then it becomes hard to understand what's going on once you have a giant system.
Mm-hmm. So this is like Scala's immutable collections, and you're saying the immutable control structures means when you write your session generator, nothing's changed. If a number of lessons come in to the input and we need to select one, then that one comes out the other side.
Yes. Another example would be, let's say, if you pass, for example, you have a set of exercises, and in one part of the algorithm, you want to filter and consider, let's say, half of these exercises because they're better in that context. So you filter your pool to half, and then you do whatever you have to process. But then in your next step, you wanted to use the actual full set of exercises, and the data is there because you have not touched it. You created a new, smaller set in the previous step, which if you want, you can use it or not. But the idea is that your variables always stay the same. So if you want that entire pool for the next step, you're guaranteed that nobody changed it, nobody removed things without you realizing.
Mm-hmm. To make this rewrite work, it's quite a different model of operation. So did you have to change the architecture of the session generator so that it could work more as a, transforming inputs rather than, mutating them?
Yes, so we did change. So many of the algorithms we had to just rewrite them in a immutable way. Sometimes when the algorithm was way too hard to rewrite and it was risky to introduce errors, then in those cases Scala has this nice thing that or I don't know if it's nice or not. People might disagree, but so you can write. So it's almost So you can port Java code to Scala and just run Java libraries in Scala because both of them run on top of the JVM. And what this means is that Scala also supports things from the Java world. So mutable types and some for loops, while loops that are not very functional in the sense of functional programming. So if you're rewriting something and then you realize that, this will be very hard to rewrite without adding complexity or making risky changes, then you can write in a more Java-like idiom of Scala.
What percentage would you say is more of a, Java written in Scala, and what percentage did you kind of go with this functional transformation style?
So in our code base, I'd say that more than 99% is functional because we try to do things in a more... So when you're using immutable collections and when you're using referential transparency, things are much easier to debug, much easier to maintain. So we try to make things immutable and referential transparent, and functional in general in most of our code base. Most of our code bases, maybe one or two algorithms, we thought it would be better to just use the non-functional version.
Wow, 99% is it's very functional.
Yes. When you're writing a code base from scratch, you can also do unit tests that you couldn't do in your monolith. So things are much easier to just test that your algorithms are working as expected.
How is unit testing in Scala?
So we use in Scala, or should I say, like in our whole framework. So we use Finatra as our HTTP server, which is Finatra is the HTTP server written by Twitter, and they use Juice, which is the Google library. And so unit testing in this context, we have like all dependency injection out of the box. We have mocking out of the box, and it's very easy to do everything. And I'd say that it was just easy to write unit tests, and we end up writing a lot of them. And I think our coverage right now is somewhere along 70%, maybe.
Nice. So back to the architecture. What is the session generator? You mentioned microservices. Is it something that calls out to a bunch of services and combines them together, or how does it interact with the rest of Duolingo's infrastructure?
Mm-hmm. So we do have so we have to pull data from a lot of places, and we have a data pipeline for that. And the data pipeline is right now just a task that runs offline, so that we don't make real online traffic depend on our data stores. Right, so we have this task that runs daily and hits all of the services and whatnot that we need to hit in order to fetch the data. And then this task pre-processes everything and then serializes all of the data this pre-processed data into S3, which is a file server by Amazon, AWS. And then when we are in online, we're serving actual requests for users. What we do is we just fetch from the file server and cache it in memory and serve it. And when we do that, we have an architecture, a system that's very robust to failures, because your only real dependency is your file server and network, of course. And also it's also very fast because everything is cached in memory.
So the only real external dependency you have is S3, and then even that is kind of insulated by your cache.
Yes.
So with all this functional idiomatic code you're writing, does that mean the session generator is sort of like it takes as an input like a user, and then all of the possible lessons ever, and then it spits out like what they should learn next? Is that
a little bit? So it actually takes as input. So the online part of the session generator takes as input the lesson the user wants to learn and some other user settings, and outputs the session to the user. So the collection of exercises.
Okay. There's an idea that statically typed languages are more verbose and dynamic languages are more succinct. So I've actually found in my experience that Scala is a very succinct language, maybe even more so than Python in some cases. What did you find in terms of verbosity, moving from one language to the other?
Yes, so I think verbosity depends a lot on the language itself. And so if you're familiar with Python as your or Python or JavaScript as your go-to dynamically typed language, and Java as your statically typed language, then I would agree that yes, because Java is super verbose. But then we have Scala is a language that is concerned about, a lot of typing. So there are many, so Scala tries to infer types whenever it can. Sometimes it can't and make some errors here and there, but usually it's able to infer your types, sometimes infer other things that the compiler can infer. It makes, like Python, you can do list comprehensions and write one-liners instead of like in Java, you need to write 3 or 5 lines of code just to do a for loop. And so Scala is very, very succinct, and there's not as much typing as a language like Java. And compared to Python, I'd say I don't see. Oh yeah, in some cases, Scala is less verbose. For example, when you're defining a class, you don't actually need to write much. Basically, if you don't need a body, you don't need to write a body for Scala.
Are you using implicits within your code base?
We are using, so in Scala, there are two kinds of implicits, the implicit parameters and the implicit conversions. And well, so the implicit parameters is when you basically define what some of the parameters of your method as implicit, and then as long as you have within the scope of the caller a variable of that type that is also an implicit variable, it's declared as implicit, then you're able to just not write the code to pass that value into the function. So it's basically to avoid typing. So for those, we do use implicits. We don't use implicit conversions because we usually find that a little bit scary because you won't see when things are being converted. So generally, no implicit conversions, but we do use implicit parameters.
And what's an implicit conversion?
Yeah, so an implicit conversion is when, well, so you have an object of type A, and then let's say that you want to convert it to an object of type B. There is a mechanism in Scala that you can define your conversion from type A to type B, and if you put that conversion in your scope, you're able to convert it from A to B without writing code to convert things.
So it could be very handy and save on typing, but also maybe you don't know what's changing to what.
Yes.
In my experience, Scala code can be less prone to runtime bugs. I think you mentioned you had some issues with runtime bugs getting to production in Python. So how did this change now that you've rewritten?
Yeah, so in Scala, we do have a lot less runtime bugs. Part of it is because your compiler will just get most of the errors. So as long as compilation passes, you pretty much have, you don't have like programming errors. You have like application logic bugs here and there, but that's another problem, right? So the compiler does a lot of stuff for you. And also the unit testing framework is also very user-friendly. So we can write a lot of tests that that makes sure that your code doesn't have like the most common application logic errors that you'll know about. So in the end, it's very hard to have these runtime bugs going on in Scala.
Mm-hmm. What did you find to be the pain points of moving to Scala as a language?
Pain points. That's a good question. So I was actually more fascinated that Scala is as a modern language. It has so many nice things that we don't have in Python and Java that kind of outweighs pain points. And there are some pain points, but I would say that they're not actually like the language itself. There are some small things here and there in the language, but it's not a big deal. Most of our pain points were, let's say, we have a library in Scala that it's like underdocumented, or we have a function that's available in Python by default or in one of the common libraries and it's not in Scala. So there are like some small things, but I guess that's true whenever you change a code base from one language to the other.
Nice. You mentioned there's some things about the language that fascinated you, such as?
Okay. Let me see what are the things. So I think one of the things is functional programming in general, and how easy it makes how easy it makes to read, how readable it makes your code, because and also since the language is not two verbose, the end result is that your code is very explicit on your application logic instead of having like a boilerplate of just like controlling your loops or things like that. And so I find the code in Scala very readable, and that's nice. It's also very easy to just look at the code and see if there's a problem, because it's all immutable, and it's just easy to debug even without running any code. And also, so I originally started my life as a programmer in Java, and then when you're in Java and you move to Python, the first thing you think to yourself is that, oh, this is a lot less verbose. It's much faster to write stuff. And then there's also that difference. Like Scala is it's very fast to write code. So in the end, I spend my time not only writing code, but all of that extra time that I would either spend, just typing in Java or testing things in Python. I use that time writing unit tests in Scala. And in the end, it's that confidence thing. You can write code and be confident that things will work as the way you expect.
You are building a data-intensive application. Maybe it involves data visualization, a recommendation engine, or multiple data sources. These applications often require data warehousing, glue code, lots of iteration, and lots of frustration. The Exaptive Studio is a rapid application development studio optimized for data projects. It minimizes the code required to build data-rich web applications and maximizes your time spent on your expertise. Go to exaptive.com/sedaily to get a free account today. That's exaptive.com/sedaily. The Exaptive Studio provides a visual environment for using back-end, algorithmic, and front-end components. Use the open source technologies you already use, but without having to modify the code, unless you want to, of course. Access a k-means clustering algorithm without knowing R, or use complex visualizations, even if you don't know D3. Spend your energy on the part that you know well, and less time on the other stuff. Build faster and create better. Go to exaptive.com/sedaily for a free account. Thanks to Exaptive for being a new sponsor of Software Engineering Daily. It's a pleasure to have you on board as a new sponsor.
So you're back on the JVM. So you got tired of the JVM and you left, and now you're back, but the language is more fun.
Yes, exactly.
I think you mentioned this, but do you find, is it faster to write Scala, slower but worth the trade-offs, or compared to Python, compared to Java?
I'd say that it's a bit slower than Python, but there are caveats on it, right? So it's slower to write a piece of code, but then the amount of effort you have to maintain that code and to test that code is a lot lower in Scala. For me, it's in the long run, Scala is just a faster language than Python.
So not faster to initially develop, but faster like the all-in time?
Yes.
So how about maintenance? So maybe you don't know. Maybe this is so new that you haven't had to do much maintenance of it, but
so we haven't done that much maintenance because the system is very new. Whenever we have to refactor something, it's very easy to, because your IDE does it for you basically. So you don't even need to think about it. You just click 2 buttons and that's it. So
the compiler gives you confidence, I would imagine, too, around these refactorings, because you get some sort of error checking.
Yes, exactly. So I remember the first time I had to refactor some stuff in Scala, I was just surprised that in Python it would take me an hour, or maybe not an hour, but a lot of time. And in Scala I finished in less than 1 minute. And I was just so surprised. I mean, it's the sort of thing that after working with Python a lot of time, you just become so used to that whenever you have something nice, you're like, oh, that's nice.
Scala being on the JVM, in a lot of cases be much faster than Python. Did you have any sort of numbers about that?
I wouldn't say so we haven't actually done any benchmarks that you would be able to trust, like that compares the exact same code in one environment or in the other. The one thing that we have going on is that we've written the whole system, the whole session generator in Scala. We have also re-architect things, and some of the performance gains that we saw was from re-architecting and using the in-memory cache and using S3, we decreased latency from, I don't remember that, it was maybe 700, 800 milliseconds to things to the order of tens of milliseconds. So it was like more than 10 times. That was very good. The number of servers that we need to use to serve the same amount of traffic decreased by, how much was it? It was like to the order of maybe 10 times or so.
Wow, so that's a big savings cost to the bottom line, I guess.
Yes. And also just the fact that, Scala and the JVM in general does better in multi-threaded environments and multi-processing, and is able to just run a lot of stuff at the same time. It's nice. Yeah. So one thing that Scala has that Python does, for example, is it's called futures. So what a future does is basically it's unit of asynchronous computation. So whenever you do a request, you get the response a future, but the value is not there. The value is you're waiting for the value in another thread. So what happens is that you don't block your original thread. And because of that, you're able to do a better job in concurrency, for example. And that's one thing that we see in Scala is that our servers are able to handle a lot more concurrent requests than Python, because in Python you have like UWSGI and whatnot, and then whenever you have a request and then you're waiting for I/O, that thread is completely blocked. And if you have, I don't know, let's say 20 threads in your server, then you have one less to serve traffic.
Is there a Python way to deal with this, or there's just not?
Not that I know of, or not out of the box. Maybe there might be some libraries that do, for example, the actor model, which is something. It's the thing that languages like Elixir and Erlang do out of the box too. So it just handles concurrency better. I think there's something for Python as well. There's Akka. It's a library for Scala. And if you use that, you might be better off, but not out of the box. Not if you're using like Flask or Pyramid.
Are you using the actor model in your session generator?
Not in the session generator, no, because we wanted to. The interactions with I/O are very simple in our session generator, and there's also the overhead to get it set up first, because nobody in the company had that kind of know-how. So we chose to first to do the more common approach, but it's something that after you start reading, you become interested in.
Are you using actors at all? I'm just curious because you mentioned it. So
I was thinking of implementing that for the offline part of session generator, because we have a lot of data, and in that situation it wouldn't make more sense to have a data pipeline that uses actors. For now, we still haven't had the opportunity to do it, because we're still working on some other things, and that's not the highest priority yet.
Makes sense. So now that your rewrite is over, what were the business benefits of the rewrite? Like, was it a success?
Yes. So for now, I think it's a success. It's not completely over yet, because we have still some features to port, but it's mostly done. I would say it's a success because of we were able to have like those cost benefits. It's just a lot cheaper to run or to serve traffic with the rewritten code and the rewritten architecture than the original one. Also, in terms of developer productivity, it's also very good, because it's a bit weird if I say it, but my feedback, but the feedback from the other developers is that it's just less painful. And I think painful was the word they actually used.
So what makes it weird?
Well, I started the whole process of moving to Scala, so I might be very biased towards the new system.
So you don't find it weird, but other people do? Is that what you're saying, or?
No, it would be weird for me to say because I'm biased, but other people, I also
Oh,
got feedback from other people that, well, it's less painful. It's that thing that I talked about. With like, you can write code with confidence, and I think that's like very important.
okay, I understand. Would the rewrite have been successful or as successful if you had made the architectural changes, but not the language change?
I think partially. So we would have with the architectural change, we would see improvements in latency. I think in Python they wouldn't be as large. One reason is because Python is a bit slower than Scala. The other reason is that having a thread safe cache in Python is not as trivial as it should be. So I think that would be one problem. But also generally we would lose all of the benefits of developer confidence, of not pushing breaking changes, because it's all dynamically typed, and it would be much harder to make like larger changes, or just to know what the data structures are.
What is it like working at a company with such a focus on learning? Like, I think, are you a language learner yourself? Does the company have a learning perspective based on what it does?
Yeah, so I think it's very interesting to work here. So I am a language learner. So my native language is actually Portuguese. So I was born in Brazil. I'm a Japanese Brazilian, so my native language is Portuguese. Second language is English. I've learned Japanese, and I kind of know Spanish. So, and it's very fun to be surrounded with people who have like the same interests, and for learning. There are some people who are learning like a ton of languages, and they know a lot of languages. And even with our community, sometimes when we meet some members of our community, it's like very interesting because they have all this view of the world that you don't usually see in your daily life. People who want to learn new cultures, learn new languages, and like have like very broad horizon, I'd say.
Yeah, I could see why that would be refreshing. People, talking to people who have a global perspective.
Mm-hmm.
Well, it's been great to talk to you about this rewrite, and I'm glad it's been a success. Thank you so much for your time.
Yeah, thank you for inviting me. It was great talking to you.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or a real user. And that's why we use Incapsula, to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Incapsula checks that request before it reaches our servers, and it filters the bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Incapsula can protect API servers and microservices from responding to unwanted requests. To try Incapsula for yourself, go to incapsula.com/2017podcasts and get a free enterprise trial of Incapsula. Incapsula's API gives you control over the security and performance of your application, and that's true whether you have a complex microservices architecture or a WordPress site, like Software Engineering Daily. Incapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers are filtering your content for attackers, and they're operating as a CDN, and they're speeding up your application. They're doing all of this for you, and you can try it today for free by going to incapsula.com/2017podcasts, and you can get that free enterprise trial of Incapsula. That's incapsula.com/2017podcasts to check it out. Thanks again, Incapsula.
Wow.